Well, hi, and welcome to my shop this morning for a little bit of a late start here for me. I slept in. Oh my gosh. So, what I want to do with these radios today, I really want to explore the linearity of the tuning range. And that would be the linearity of or the way, maybe not linearity, the way in which the local oscillator and the front end tuning track the dial across the front, which is a big part of all these radios. It's got to be a part that the designers work on really hard to make these things line up over the band. And if you think about it, the AM radio band's a tough one because down here it's around 500 kilohertz and here it's 1500. That's a factor of 3 across the range. Most radio tuning, there's no factor of 3. It's more like 0.3 or something like that. So that's quite a range for the radio to operate through. It's quite challenging, in fact, I would imagine. And so I wonder, in these older radios, let me say this. The last stage in the radio design, as they try to make all this stuff linear in that, is to create a dial which matches the result of the radio they designed. So they just can't quite get it perfectly linear and balanced through here. They compensate with the dial markings at the end. So that tells me too how difficult this really is. If it were easy to do, all radios would have perfectly linear dials on them. How can I show this? The distance between 60 and 70, so that's 10. And you can see the distance of 10 is much smaller at this end. That's what I'm getting at. So what I'm going to do, the way I'm going to approach this, I think, is I'm going to do the alignment process for both these radios, the oscillator and the front end. I'm going to do as carefully as I can and try to get it exactly right as best I can. And then I'm going to go another step, one I've never done before, and I'm going to this is my thinking right now anyway. By the time I get there I might be thinking something different, but I imagine I'm going to write down all these spots on a piece of paper, the frequency for them, tune the radio to that spot, and then make note of the local oscillator frequency and also the front end tuning peak. And I write it down on a piece of paper, and then when I'm all done I'll take those numbers and do something to make it apparent how the radio sweeps through its dial. And my opportunity here is I have two identical radios, and in a sense I have four identical radios. Not quite, I have two pairs of identical radios. That gives me this opportunity to compare things back and forth, and that's why I've been working hard to make these radios as identical as possible. So this stage now will work. And I've had this in the back of my mind for years, that I've been suspicious that parts we never change in these radios, coils in particular, change as the years go by. Do they really? Well, think about it. It's a little crazy to think they don't change. Everything is changing over time. So what changes would occur in a coil? Moisture getting into the insulation, or who knows what might be changing in those coils, and how would that upset the tuning? It may be you can never get it to match the dial again. And my last thought on this before I start going is when you follow the alignment instructions that were provided by the manufacturers, they weren't imagining it being done in the year 2020. They were thinking it was being done 10 years after this radio came out of the factory. In fact, often they're saying, don't do it, don't align a radio, just leave it all alone. What was in their minds was, if a radio were to have a problem like a tube failure, and if you replace the tube, the bulk of the radio is still factory equivalent. And so anything that they had done in terms of how they've made the coils and all that kind of stuff, so it all works properly up here, would still be in place. So you throw a new tube in or change one capacitor and everything else is pretty much the same way it was. This is going to work the same way. And you're going to be able to align the radio at one frequency, maybe two, and everything's going to work fine. Because the set's behavior is the same back then as it was the day it came out of the factory. But here we are in 2020. How do I know that's still true? So the instructions still say, do the alignment at 1400. and then you're done. And you can do that for sure. Put all your equipment on, set it all up, get it all 1400, great. And what's happening on the rest of the dial is my question. At that point, I think in the early days, the assumption was if it works here, it'll work everywhere. And I think that's an assumption now. And I think I've struggled with this on a few radios. And once in a while, I get a radio in here that does actually still line up perfectly, and it stands out. And this freaks me out too, freaks me out a lot. I've aligned a lot of radios. I've probably brought them all up to, well, as good as they could be following the standard instructions and that. I want to gain the insight of what is going on a little bit further in the radio. So from now on, when I'm doing alignments, I have this additional knowledge and experience. And these two radios are giving me the chance to do this. If I just had one, it wouldn't be sure about anything. So what I'm hoping is both these radios will behave essentially the same way when I do this. And I'll be very reassured about the result, whatever the heck the result is going to be. Okay, hey, that's a lot of talk. So I'm going to get these guys, they're not even on yet. I'm going to get them turned on, warmed up, and then we're going to set about doing the alignment. Should go pretty quick. And then I'm going to start the experiment after that. Okay, did I say something about I might change my plans? Yeah, I'm going to change it a little bit. I'm going to do the alignment using the SDR itself the whole time, and we'll be able to answer these questions as I'm doing the alignment, or at least get a feel for them. I'll still do the final study, but it's really quite simple using the SDR. So, let's start. Now I've got the radio on full power, it's all warmed up, everything's warmed up and ready to go. So I still haven't changed the string on this. It won't affect the result other than making it tricky for me to turn the dial. That's all that will happen. So first thing I want to do is set this to, we'll follow the frequencies initially. 1400. Let me make sure it's right on 1400. Well, that's about as right on as you can get. Thank God this dial makes sense. The baby champs have a squared off dial, which just gave me no end of problems trying to figure out, hey, where you got to tune. This is nice. 1400. So we'll just take a look at the local oscillator frequency now. It's sitting right here, and it's at 1925. I'm going to write that down. I didn't have to write it down. What it should be is 14 plus 455. It should be 1855. So you can see it's off. 1855. So I'm going to put the line on the SDR. I'm going to put it at 1855. 1855. Oops. There we are. So this red line is where we want the oscillator to be when the radio is pointing to 1400. Let's double check that. 455, 1855. 1855, no doubt about it. So we're at the high end of the band, so we want to adjust the high end of the band oscillator trimmer. I gotta get myself some kind of tool to do it here. Let's see now. It's a little awkward getting to that trimmer screw. Not gonna do it. This isn't going to do it, it's too flimsy. Okay, I got it. So now we're going to move the oscillator all the way down there. Okay, there it is. That's good enough for now because we've got to come back to it in a second. Now we'll go down to 600. Wasn't it 600? It was 600. So frequency they recommend. I really don't need to listen to it. That's as low as I can get the volume. 600. So now we look at the local oscillator. Should be at 1055. And we'll put the red line at 1055. Where are we here? 1055. So it's very close. So make a small adjustment to bring it up. That's done with the trimmer back here. Yeah, you can. Okay, so what this is exactly, I don't know, but we'll just ignore that. This is what we're really concentrating on. Get this one quite accurate. There. That's pretty good. Now we'll go check the 1600 again. 1400. Okay, I think that's 1400. The oscillator should be at 1855. So 1880. So 1855 is here. And move it there. So again, we'll use the top end adjustment. And move the oscillator. Okay, got it right on there. Back to 600. Change the oscillator here. I didn't write it down. It should be 1055. I'm gonna write it down. Just reduce the chance of me making a mistake. 1055. Where is it now? Pretty much dead on 1055. Okay, make a very slight adjustment. A lower end trimmer. Slight adjustment. Slight. Slight is right. Okay, I'm not going to get any closer than that. Check the upper. Again, now let's just think for a minute. What is this? This can be an artifact of the SDR itself, this thing up here. 1055 times 2 is 110, and that's just where this is. So, what's the significance of that? There's a second oscillation here. Don't know, it's way up there out of the range. Yeah, that's interesting. Okay, well, it's interesting, but we will ignore it because I'm on my way to doing other things. Now it's time to do the front end part of this deal. So let's take a look. So we have the radio set to 600. And if you look at 600 on the SDR right here, you see the tuning peak sitting right there. Now we're going to tune the radio up to 1400 and see where that peak ends up. Okay, up to 1400. Okay, we're on 1400. So it looks to me like the peak is here at 13, not at 14. You can even hear the radio's tuning kind of change as I got up into this side of the band. It seemed to change the sound coming out of the speaker. So we want this to be up here. There's only one adjustment. It's the high end here. Let's adjust it. Oh, this is a tricky one to get to. Okay, I got it. In case you can't tell what I'm doing, I'm going through a I think it's a little better to look like this. I'm going through a hole in the antenna. Probably there for this purpose. Okay, let's move that peak now. Well, yeah, I'm gonna have to do this with a metal screwdriver, I think. It's a fairly long one. Let's try this big monster here. Whipping in a bunch of metal and looking to see if the SDR is doing anything while I do this. No. Touch the screw. No. Okay. Move that to the red line. So I'm listening to it too while I'm watching, but I'm mostly watching what's happening. Now, here's the deal. If there happens to be noise right next to, say, right next to 1400, I could end up kind of tuning to the noise. So I think that's got the peak on 1400. Let's tune the radio a little bit and see what it looks like here. I would say, I'm just looking at the SDR. I'd say that's 1400. Right on the money. Well, maybe not from up there, from down here. Very good. Okay, so at this point, the local oscillator and the front end have both successfully tuned at 1400. Everything's great. Pointing, everything. We'll go down to 600 now and see if it survived the... see if the front end goes down there with it. Okay, that's 600. So first, is the local oscillator at 1055? 1055. Right on the money. The tuning peak is just a wee bit off 600 here. How far off? So I'm going to tune the radio to move the SDR peak right over the 600. So I'm hardly moving it. See, it's still not quite on it. It's still within the bar. So just judging from the little peak there at 600, you don't have to be too far away from 600 to be outside the peak. You know, 610, 620. You got to be really dead on. That local oscillator's got to be dead on. It's not. And with the tuning peak a little bit above 600, the oscillator should be a little bit above that red line. It's below it. So I have my choice now of fooling around with the oscillator to bring it in line with the tuning peak. You know, the oscillator stretches at both ends. It's got two capacitors, but the tuning peak, the antenna tuning, only has one. So I can only do one. I get, you know, I can't stretch. I can't really fit. Oh, maybe that's the whole reason for why they've done this radio this way. You have the front end tuning and one trimmer to set it, and then you have two trimmers to try to match the local oscillator to it. And then it goes back to my earlier idea that in the early days the thinking was these radios are all linear, everything's great, so if you can align them in one spot, you've aligned them in all the spots. It gives you two instructions to do the local oscillator because you need to stretch it. So you fix it here and fix it at 600, and it's going to be stretched to match, and we're going to find out if it really is stretched to match. So I'm going to adjust the local oscillator at the bottom end. I'm going to forsake the dial a little bit. I'm thinking about this quite a bit. I've sort of decided that dial accuracy is probably the least important factor in this. It's really a local oscillator and front end tuning alignment that's critical in the operation of the radio. If you can't get all three, you forsake the dial. That's my thinking here. Okay, so now we have the local oscillator where it should be. The radio will be tuning 600 right now, right in the peak of the front end. So now we'll go up to the other end and check it again. I did a video a while ago called, I think I called it Alignment Perfected. And it was using this technique, basically. I've had this in my back pocket all the way along. Now, so we can see there's something sitting there at 1400 making a pretty bright line on the SDR, but well, I guess it's the and I haven't explained this the whole time. We've been using the sweep generator up here the whole time to do this. But the sweep generator output on this loop up here, just hanging above my shop. So the radio is picking it up with its own antenna. The sweep generator is sweeping way across the AM band, starting a little bit below, so as not to get into the IF frequency, and then it's going quite a ways above, 1800, 1900, something like that, sweeping away. Right, so we're tuned to 1400. Is the local oscillator where it should be? Where should it be? It should be at 1855. No, it is not. Is this peak where we think it is? Well, I can only adjust it kind of once. I only have one adjustment anyway. Looks okay. So the peak seems broader up here, and the number of, yeah, I would say that. So let's move the oscillator again. We're stretching. We're stretching the oscillator. I think I finally figured something out here after what, 10 years of doing this? Upper oscillator up here. Okay, dead on. What happened now at the other end again? So doing this, with the SDR, this is fantastic. Compared to trying to do this with a single frequency generator, and I'm sure if I could show up in 1950 in some guy's shop with this arrangement and say, hey, watch this. Well, the guy'd end up in a nut house afterwards, wouldn't he? Excuse me, I'm getting a phone call on my cell phone. What? Poor guy. Wouldn't it make their heads come off? Won't it make my head come off 30 years from now with what's going to be around in this world? And I'm hoping my head is still on, actually, 30 years from now. Concentrate on what we're doing. So we're at 600. Peak is right around 600. Local oscillator is now at 1050. So see, it's off enough that you'd be outside the peak here. Okay, so we're gonna stretch it back. We're gonna move it back. Now that's the lower adjustment. Screwdriver, please. lower adjustment. Can you tell I'm a little excited about this? I feel like I'm graduating to alignment university or something. Turns out it's a 9-year course. Okay, we're bang on there. Now we must rise up to the other end. Now every time I do this, of course, I don't get the radio tuned exactly the same. I haven't taken steps to guarantee that. It's just my eyeball on there. Okay, and local oscillator location is... All the work I've done on these radios, and I've only now really realized what they're setting up here with one trimmer on the front end and 2 on the local oscillator. And I'm making use of it. That's for sure. We're really close now. It's supposed to be 1855 up here, Jim, not 1860. Okay, we're not quite as close as I thought we were. So we'll bring that back in line. Go down to the lower end again. Well, that looks like 600 to me. Okay, the front end peak is sitting at 600. Local oscillator is supposed to be 1055. My gosh. I don't think I've ever gone back and forth this much in a radio, but I have a feeling going forward I'm going to be paying a lot more attention to this. Not relying on just the instructions. I suspect the instructions are only valid in a like new radio. To the other end. $14. Is Let's just keep working away at it. In a sense, upper one. Did I make a mistake there at one point? Maybe I made a mistake, like I did the wrong trimmer at the wrong time. Doesn't seem to go a long ways. I think maybe I made a mistake back there, which you might have seen me do. Okay, we're on 1855 again, and also it's really has to do with how well I dial up this thing every time too. 600. $10.55 right on the money. Peak at 600. Let's move the peak slightly, the tuning peak. So it's right on. The lower end of the band is more important to me than the upper. Can we move it? So this adjustment is much more sensitive at the upper end. Well, by moving this a long ways, we got there, but that's a long ways. I'm going to move it back a little bit. I have the feeling I've messed it at the other end, but we're going to find out. 14. Still off a bit. Now I'm going to tune this because I suspect that a little bit is just me not getting this. This could be like a hair width. Okay, would be happy there. That's really, yeah. Okay, I'll make one more adjustment. High end, this one. Oh my God, can I get any more accurate than that? I'm going to stop at 900 in a moment and find out what happened in the middle. 600. $10.55. Okay, we're going to stop at 900 now and find out what happened. It's right on 900. 900 would be 455, 1355. 1335. 1355 is up here. Tuning peak is down here at around, it's not at 900. Okay, so what I'm going to do now is I'm going to do what I said I'm going to do. I'm going to do that study. I'm going to go across the band. I'm going to measure the local oscillator and front end resonance across the band and see how they line up and vary as we go across. Because I think they line up at 600 and they line up at 1400. Okay, I'm not going to do that on camera though. It's going to take me a little while to get that done. Whoops. Oh, I can't make this. Yes, I can make this radio quieter. There we go. Okay, so here's the results from my little experiment. So what I did again was I tuned the radio to each of these settings very, very carefully based on the dial. And then I simply wrote down where the antenna peak was and the local oscillator target frequency. So I took the local oscillator frequency, subtracted 455 from it to get that. So you see at the first one, that's great. The local oscillator is aiming at 550 and the antenna is aiming at 550 and the dial is pointing to 550. Thumbs up. It's downhill from there though. So when you get to 600, you can see this is starting to fall behind a little bit. Now bear in mind, this is all based on my ability to tune that radio based on the dial. You know, these are not precision radios, so, and the dial is not a precision dial. So it could just be me. Let's go to the next one. We see the separation's gotten bigger. Here it's 2 kilohertz. Here it's 8 kilohertz. Whoa. 2 kilohertz. Back up. It could be just, this might just, you know, be the way I tune the radio here. 22 kilohertz high. So I'm trying to tune for 12. The front end is low. It's aiming for 1185. That's low enough, it's missing 12. The peak is sharp enough, it's not really doing much. Well, it's doing a bit here. For me, one of the local oscillator is actually trying to pull in stations at 1207. 22 kilohertz. 22 kilohertz? Yeah. We go up to the next one. Dial up to 14. Now this is where I set the local oscillator very carefully, but it's no longer set. Again, this could just be me tuning and not hitting the center of the dot, although I was extremely careful to get the pointer on the center of the dot. It could be play in the tuning. You tune it from the left or tune it from the right. The same pointer setting, the capacitor is actually in a different position, stuff like that can happen. 32. And then the last one I did when aiming for 1600. The front end is tuning 1560 and the oscillator is aiming for 1650. 1560, 1650. Somehow I didn't get confused there. So that's 90 out. So now what I'm going to do is we're going to tune the radio through here and we're going to listen to it and see if we can't hear what it appears to be doing, which is kind of drifting way off at the top. What would this sound like? We're going to find out, because whatever it sounds like is what a radio like that sounds like. Okay. So I'm gonna remove this little thing here, which might be adding a little. So it's just the radio and its antenna, radio on its side. Nothing really hooked up to it. The other radio is operating over here, so it has a local oscillator. It's dialed up past 16. Hopefully this one's not going to interfere with anything we're doing over here. So I'm just going to tune. I don't need much volume on this radio. So I'm just going to tune down. And what we know is that around about 700 things get really good. So basically it's great, good, not so good, really poor in terms of alignment. So somewhere around here, the misalignment crosses. So at some point they're bang on, unless it's just me not being able to tune the dial accurately. Let's keep going now. It's gotten way quieter here. Counterintuitive, isn't it? The test I did has nothing to do with the level of the signal or volume or anything. Just picked up a station there. So generally speaking, this radio is very quiet down here. The interesting thing is, if you asked me just from listening to this radio, I'd hear the noise up here and I'd say, you know, it's better aligned up here because it's more sensitive. It's picking up more noise. You hear it get quiet down here? Probably the local oscillator and the front end are not lined up. Boy, would I be wrong. Or am I wrong? Has this wandered off while I've been fiddling around? So let's double check. We're right on 600 here. So we'll double check. I'll flip the I'll flip on. What am I going to do? Flip it on here. Like this. Oh, you know, I've taken off the pickup coil. Let me put it back on there. Listen to this change. And any one of you might argue, wait a minute, you're putting a piece of metal right on the antenna. I fiddled with this earlier and it didn't seem to have any bearing on the radio's receptivity, having this extra little pickup coil sitting up here. Okay, why no front ends visible? Why nothing is visible here? What has happened? What did I do? What did I do? So I see the local oscillator coming and going. What happened to the front end thing? Hey, what's going on? No sweep signal, Jim. There it is. Tuned to 600. You can see there's this peak at 600, and at 600, 1055 is where the local oscillator should be. Just a touch low, a hair low. And what did I at 600? You know what? I have it shown as a touch low in my chart too. While we're here, I can actually adjust it. Why not? So we're bringing the local oscillator bottom end adjustment up ever so little, up. And you can also ask questions about, hey, how accurate is your SDR? These frequencies, it's very accurate. I checked that. Okay, so what are we going to do now? Let's go back up to 1600 and verify the wild numbers I got up there. Very convincing that it's tuning it. What's it tuning? Bunch of noise. Okay, 1600, middle of the square. Oh, it's a little tricky to spot the peak in this curve. I would say. Let me move it a bit here and watch it. Okay, I'll set it back to 1600. By my eye, the peak is sitting right here. 1560. I wrote down 1560 last time. And now we'll check the local oscillator. Okay. And then I gotta subtract 450 from that. 2112, 2112 minus 455, 1657. It's worse. Before it was 1649. So it's almost as if when this radio gets up in this part of the band, the local oscillator takes off. It just a little bit of movement here, and the local oscillator jumps way up. It disappears. And what does that sound like? Why does this radio get quieter? Well, we gotta tune a regular. Now that's interesting. Okay, so what we're hearing, the buzz, is the sweep generator running here, and the antenna, like I showed you up here. That's the radio station. The buzz is the radio station. Let's listen to the buzz. See that buzz get weak? Buzz getting weaker. Buzz almost gone here. So the sweep is being overtaken by noise signals. And why? Bad alignment. Buzz. Nice buzz. Nice buzz. Bad buzz. I think that's it. I think that's what you could find in a radio like this. You could grab it, whip on the sweep, listen to it, swing the dial back and forth, and make an assessment of what it sounds like. You think so, Jim? I happen to have a radio ready to do that with. I just wish I could quiet this guy off. Okay, so we're kind of done with this one. So I'm going to switch up my attention to the other one, which has been sitting here. I'm going to switch this one off. Oh, wait a minute. What happened there? I switched this off, it didn't go off. Panic. What happened? Tell me the switch has failed while I've been working on this radio. Well, that's what's happened. I gotta shut this one off so we don't hear this. So I'm gonna pull the plug on it. I'm gonna mark the plug polarity while it's in the thing here. Okay, which one's which? Okay, I'm going to unplug this radio. Okay, now it's all about this one. Okay, so we're going to perform that test. I'm going to move this. This is the pickup coil. This is all it is. It's just my lead just clipping together. That's it. adding a little bit of an antenna here. I said before, this doesn't make any difference. Hope it doesn't. It doesn't make any difference for the tuning of things, I don't think. I'll experiment in a minute and find out. So the test was just sweeping through and hearing what it sounds like. Where's the sweeper? Where's the buzz? Here it comes. What's happening there? Well, you know what? This is really interesting. Okay, so 600 is one of the places where you adjust the radio to bring it into alignment. And look, it's working great at 600. Nowhere else though. So this is kind of what I was afraid of, the idea that maybe these radios really just can't be aligned at one frequency. Coupled with the fact that I really was reckless when I did these radios because I had it in my mind that this day was coming. But once again, you hear all the nice noise up here. It makes you think it's working better up here. What we're going to do next, we're going to do the checking of the condition before I start fooling with it. Then we'll do a quick alignment using the SDR, and then I will do a check all the way through the band, and we'll compare these two radios in the end, see how they are. Why don't I just keep going? Just keep going. Just keep going. Get it done. Well, it's 1600. We'll check it up here. Okay, it's right on 1600. Okay, so looking at the SDR. 1600 should be 1855. So this should really be here. This should be way over here. Wow. Okay. I was reckless. No, I wasn't. I had it perfectly tuned at 600. Oh, let's go. Let's go with the oscillator. Oh, those noises went away. This capacitor is getting really tight. So what I'm going to do is I'm going to loosen it a touch because it's too tight already. Never even got there. Okay, and I'm going to fool with the other end capacitor. Yeah. So the other end was pretty loose. I'm going to tighten this a bit more. I'm going to leave it where there's some play, and then we'll tighten this one a little bit more. Come on, you can get there. Bingo. Okay, good enough for now. Down to 600. 600. That's there. Okay. Where's the peak? Oh, it's not much of a peak. You can see it there at 600. Not much showing up. It's at 600, but it's very weak. So I'm going to adjust the antenna trimmer. I didn't touch the other one, did I? I kind of forgot about the antenna trimmer. Let's see if this guy's way out. We're trying to make that peak at 600 show up bigger. I think what I did was I made it smaller and moved it downwards, frequency-wise. Open this up. Seems to be getting bigger. think there's a distinctive peak here as there was on the last radio. Okay, so local oscillator is doing what now? It's supposed to be at 1055. Oh, way off, 970. That is the local oscillator? Yep. Look at how accurate I have to have this thing tuned. Slightest. Make sure this is really in the middle here. Okay. So I see the peak, front end peak sitting at 600, and the local oscillator is there, but it really should be way up here at 1055. So we got to get that oscillator up there. So using the low end oscillator adjustment, I think it's almost hopeless to do this with just a single frequency generator. I suppose you can, but wow, this is far, far better. Hear the radio coming to life? So radio came to life there because I basically moved the, let me point with this. The radio was trying to tune down here. And I just, by moving the oscillator up, I just moved this up until it was right at 600 and boosted by this. So I think that's a pretty good result. Now we'll go up the other end and see what happened up there. Okay, we're doing it at 1400. Did I do it at 1600 last time? We're following the instructions. $1,400. That's kind of like a cantilever sort of arrangement there. Rather than check the radio right at the ends of the band, you're checking it just a little bit in. So you figure if you get these accurate, this will be more accurate, and these will still be reasonably accurate. Whereas if you did the two ends, this might be farther out. It's the cantilever, right? Always make your boards hang over. Always make your boards hang over. Okay, 1400. We're on the money there. What do we got for a... So the peak here now is closer. I think it's here. And of course it should be 1400. So I'm gonna move that. You know, I'm really doing something a little bit different here than I did last time. I'm going to move that. $1,400. Anybody see anything moving there? So I'm trying to move the peak response. The capacitor's way open here. Okay, I think it's starting to move now. Still way open. Okay, now it's starting to tighten up. Oh, there you see it move. Okay, now we're cooking. Bringing it back. I'm gonna kind of swing it back and forth to see it. There's also a delay in the SDR of almost a second, and that makes this tricky. Okay, so there, I think it's at about 1350. Well, I'm going to have to do this again and again, so I think that's about it. Okay, and again, checking the oscillator. Up here. 1762, and it's supposed to be 1855. Whoa, 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 whoa. Is that right? 1855. Radio's tuned to 1400, yeah, 1855. This is way low. Okay, 18. 55 is where the red line is now. That's where we got to get the oscillator to go. High-end adjustment, correct radio. There we go. I can't do it with that. Can't do it with this either. Let's go down like this. Okay. Way up, way up. Way up. Okay, down to the other end. $600. The pointer on this is interesting. It's a flat piece. Can I show you that with this? Okay, so it's not just a wire. It's a flat piece like this. So I'll aim this at the camera. So if you're looking a little left or right, you can see down it, right? And it gives you a great opportunity to get it tuned right on, as long as you're looking straight at it. Okay, so 600, checking 600 now. Oh, that's where it's supposed to be, and it's not there. Let's put it there. Lower end adjustment. Again, pay no attention to that thing up around 2100. Now we'll go back up. Say, oh, 14. Don't make a mistake. 14. Okay, 14 should be 1855. 1850. 1855 looks like that. Okay, we'll go there. 1855. Wrong way. Getting away. Ah. Jumped up just a touch. Well, let's go for precision here. I mean, there's no precision. Okay, now. Well, so if I'm on the center of the square, what if I go just a little this way? Yeah, that's what I'm playing with. I'm playing with that much. I'm looking at the SDR, that much precision here. Sounds like my wife is wrestling with her cats upstairs. I don't know what's going on. 1855. Once more to 600. Still doing that. It really likes the 600 spot for some reason. 600. Checking now. Tuning thing is pretty much at 600. Local oscillator is at 1055. Okay, so we got there with this one. It's time now to do the study and see how well these two things track. So I will do that and show you the result. Okay, here's the results. I'll just turn off the radio at this point because I'm going to be going for lunch next. So, what to make of this? So, first thing is, these numbers are the difference between what the local oscillator is trying to do and what the front end is trying to do. So in other words, this is how close the local oscillator and front end are. They don't relate back to the dial setting number. Not these little notations here. This radio goes way out at the top end. Maybe I should have paid more attention when I did the initial alignment, because maybe I didn't get it right, because by the time you get up to 1600, you've got the front end way low and the oscillator way high compared to where they should. So it's a total of 90 kilohertz difference. The radio can't be working that well. Even though the fact is, at this end of the dial, the bandwidth of the front end gets a lot wider. That's what this is supposed to represent up here. Whereas when you're at the low end, it's smaller and appears to be more focused, more tighter in here. Yeah, that's enough said. So yeah, that isn't enough said. So that means precision at the low end is more important than precision at the high end, because if you can get the local oscillator working in anywhere in here, they're going to be kind of okay. Yeah, you want it to targeting right in the middle of it, because it's wider. The same error, like if you're here, would look like this down here. You'd be right outside of it. Now, there's problems with what I'm showing here because these don't end; they keep going down. But I think you're getting the point anyway. Now this one, we look at how it goes along pretty good. There starts out. Actually, there's no front end visible at 550, and the front end is trying to tune 540. I know that from tuning the radio up and seeing the front end response show up. So something a little different there. It's going below 550 here and above 1600 there, and this one was going 550 here and below 1600 there. And so what's the point? No point in even pointing that out. So this radio, oddly enough, it gets out of whack more in the middle here in terms of the local oscillator and the front end. It gets up to 14, which is enough now. You might be missing. Again, there's a tuning error of probably plus or minus 5. Maybe a little less than that, just from I can't set the dial that accurately. And then it starts kind of coming back in line again. So in this radio, the local oscillator, the front end and the local oscillator follow fairly closely. There's 14 out there. This one, not at all. They start separating here, and then they're way off. So maybe this is I just need to adjust this better, I think. Now let's look at the actual dial setting and what you're actually getting. So down at the bottom, when you dial in 55, you get 55. Well, maybe not so much on this one. 600, right on the money. 700, okay, so you're tuning in 690 here and 690 here. Tune to 90, you're tuning in 883 and 885. Tune to 1200, you're tuning in, now they diverge. You're tuning in 1207 above or 1184 below. 14, you're tuning in almost 14 here. 14 right here. 14 right here. So conceivably this radio works really well at 14. And why would that be? You know what's going on here? I'm either getting the radio good at 14 or good at 600. Well, this one's actually good at 600 too. Okay, take that back. I was thinking I'm just seesawing, it's going to work at one end or the other, but never both. And what do we get up here? You're tuning for 1600. We're low there, we're high here, but these are fairly matching. I would say probably this radio works a little better than this one, especially at the high end. The interesting thing is, both radios give you the impression the sensitivity is much better at the high end than the low end. And that could be because of this thing. This response curve is low here, and it's much higher here. So maybe it's just bringing out more of the noise into the radio. More of the, not noise, but interference signals. You actually almost never hear the noise because the interference signals are so strong. Noise being atmospheric noise or electronic noise. So what to do about this? What I'm going to do about this is I'm going to go have lunch and let it kind of steep among my brain cells for a while and decide what I want to do about this. Okay, I did get an idea of what we can do with these two radios. I've turned them back on, and my soup is gently warming upstairs. So I have a few minutes here. Why not tune these two radios to areas that appear to be out of whack and compare them and just see what happens. In fact, if I can find one radio out of whack and the other in whack where there's something to receive. I may have to make something to receive. So that would be, for instance, at 1400, this radio seems to be tuned up good, but at 1400, that radio is not. So what I'm going to do, I'm going to transfer that hanging loop to my other signal generator, if I can get there. I'm going to put out a fake station here at 1400. I just need to hand this guy up. You're going to reach. Okay. Let's get this out of here. We'll dial up, we'll set this to 1400 here. If I can get my hand through all these wires. Okay, so that's running at 1400. Putting out a you know, it's into this loop. You can see the loop kind of hanging up behind the microphone here, and that's coming down onto these two antennas. So 1400, we should hear it here. Oh, I better tune. Radio's not on. Oh, that's right. This radio is always on now. Both radios always on. I got the chassis too close together here. Too close. Come on. Come on, move. There. Get stabilized. Okay. I'm going to dial this guy up to 1400 here and see. Dial them both to 1400. I would say that's 1400. At 1400, this radio is tuning 1395. That's pretty darn close. They don't hear anything. Maybe the signal isn't strong enough yet. Set this one to 1400. I gotta do something with the volume control for sure. 1400, neither one. Speaking up. Okay, we'll give it a little more juice over here on the signal generator. Oh, this is down. Nobody's hearing it. Oh. Oh, one hears it at 1420. A little more juice. There we are. Who's picking it up at 1420? I can't tell which radio it is. Ah! This one. Is that really tuned to 14? Right on the money. 14. That's funny. When I did this before, okay, a little experiment time. Did I throw it off with this loop on here? Looks like I may have thrown it off a little bit. Nope. I've added noise into it. That's what that did. Just added a bit of noise for some reason. Okay, so figuring out what I'm doing here. 1420 being received here for some reason. Turn this guy up a little bit. Still hearing the tone out of here. Oh, I can tune this away. Okay. There it is there. This is at 1420. Let me put it back to 14. With noise, so this is right on the right frequency. Now, tune this one back in. Question is, which one of these radios picks this up better? So here we hear what this one sounds like. Go to this one. Hard to say, isn't it, really? Listening to the level of the noise with the signal. Fooled by the volume, just because the volume's higher, make it think it's all better. I think this one's better. At 1400, according to my chart, this radio's working good. Yeah, right at 1400. And this guy should not be working good. They don't match at all. Yeah, I just said this one sounds better. Where else are we? So 900 comes in at 885. This is supposed to be -2, +8. Well, let's try it out. Let's go to 900 with both these radios. Just compare them. I better go check the soup after this. Okay, 90. I get involved in this and forget. 900. Let's find it here. Can't get there. That was the IF. Lots of stuff. We can also take a look at the image response of these radios too. I'm interested in doing. So here we come into 900. Okay, so that's 880. This radio's that's what we're listening to. 900, 885 last time. This radio. Put it on 900. $880. Last time was $887. Both tuned in, right? That's fine. Just a better spot here to compare them. That seems like a good spot right there. Right where it is. So that's 890 being transmitted. That sounds nice. Oh, loud stuff, man. So if that's 890, on here it's 900. This one, it's right on 900. Both these were running a little low at 900, just like they are. This radio sounds a lot better to me. Oh man, I can't. Better in the sense that there's less noise in this radio. Not a lot different. What are we finding out here? So, okay, let's go up to 1600 and see where the radio is really out of whack. 1600, and then I'm going up. You know what? I'm gonna have to run up and check my soup here. Soup before 1600. Yeah, or else the soup would be boiling away up there. Homemade soup. Okay, soup check. Oh, good thing I did that. It was boiling away up there. So now it's cooling down a bit. That gives me enough time to check at 16. Now I've got the signal generator already set to 1600. Let's see if this guy can find it, because it's not hearing it at 16. So it's finding 16 way down here. And that matches my earlier experiment. Other radio, let me just turn this off where it's quiet. Other radio. And where is it finding the signal? Hi. Okay, let's look at what we got here for test results first time through. So this radio was 90 out at 1600 and the other radio was 7. So this one should work much better than that one. Yet to me, this one sounds better than that. It's all a mystery, but one thing is for sure. My soup is ready to eat now, so I'm going up to have some nice homemade soup. Think more about this. What can I possibly do about any of this? Anyway, what should I do? What can I do? What should I do? I should eat soup. Okay, so just in thinking about all this a little more, all these numbers and all this stuff, and I'm thinking that the two adjustments on the local oscillator, the only way I can get this across is to make a diagram here, I think. So on this radio, we have 2 points at which the local oscillator is fixed. One is at 600 and the other one's at 1400. And the idea is you adjust the the lower adjustment to get this right, and you adjust the upper one to get that right, and then everything's right in between. That's the idea. Where's my tripod is slowly falling there. What I'm thinking is, and if everything were perfect, we could symbolize it by drawing a straight line like this. What I'm thinking is actually happening, and this curve is meaningless in itself. It's just to illustrate what's going on. That it's correct here and correct here. And in thinking, it's again just pictorially that if I keep working at these two adjustments, then I will slowly lower this down to here until it is straight across. Just by tugging, more or less pulling it again and again and again. And what's happened is I've stopped short with this radio, and that's why I've ended up with this thing happening here. 32 out at 1400. I don't know how that could happen. Didn't I set it at 1400? That's what's going through my head. Something like that anyway. And the objective here is, again, taking advantage of the SDR. Forever collapsing tripod here. We should be able to flatten this guy out. Okay, I got to turn. So I turned it off while I had lunch. So I'm going to warm everything back up, and we'll get back at this again. Okay, so we're back on this radio. I've got it set to 14. Do I really? That's 14 in the middle there. Okay, and we'll take a look on the SDR and see what it tells us about the local oscillator. One, 8, 8, 1. It's supposed to be 1. It's supposed to be here. How did it get up there? I thought I did this. It needs to be there, where the red line is. Okay, to the red line. How did this get this far out? The usual answer is I got confused and turned the wrong screw at one point. This is tightening up. Okay, still got lots of room to go. 600. Yeah, you know, maybe I was interrupted or something. I didn't finish something. Hope that's not the case. 600 without parallax. Okay, 600. Radio's pretty quiet. Look on the SDR. It should be at 1055. 1055. What happened? Okay, now we're at, I know what happened. I adjusted the wrong, oh, for God's sakes, while I'm busily talking about making a mistake, I'm making the mistake I'm talking about. Oh my God, what a bozo. Okay, hold on. Or am I making another mistake? I think I really messed this up. Okay, I messed this up. So we're at the low end now, Jim. Must have been the soup on the red line. Must have been the soup. That soup was made with leftover Christmas turkey. It's delicious. Okay, we're at 1055 at that end. I'm just going to zoom up to the other end, fix my mistake, get on 14. The frequency is supposed to be 1855. The high end, yeah, I almost did the wrong thing again. Overcome some darkness here. Okay, moving it. Yeah, I'm sure I just got things turned around while I was doing this. Okay, high end good. Back down to the bottom end. I'm sure it drives you nuts watching my videos, seeing me making a mistake and knowing I'm making it, and it might be quite a while before I catch it. Low end adjustment. Oh, where are we on the SDR here? We want to be at 1055. Very close now. So I turn that just a couple degrees to get to there. Now let's just gain. How? Just gain. Yeah. You can't even see the red pointer moving on the radio, but I'm moving the local oscillator back and forth. So I'm definitely going too far with these radios. But in all honesty, this is about getting ready for a series of shortwave radios I'm going to be doing soon. Got a couple to do. 1400. Sharpen my skills on these simpler radios. Skills or techniques or something. So what happened there was I moved the whole screen just a touch. That's what that little, oh, you can't even see it. This is supposed to be 1855. Pretty close. Okay, turning the correct screw. That's about probably 3 degrees on the screw. It's hardly anything. Okay, we're on the money there. Now we go down to the other end. I don't think I can make it any better than this. 600. So the radio is really quiet. 600. 1055. Right on the money. Okay. Now, something went weird with this radio. I'm going to go back up and just double check the other end. I'm pretty sure I must have simply made an error. How close is that? This close. Well, you probably couldn't even see the pointer move. Okay, now that's done. Now we're going to go and look at the front end. So let me get the sweeper going here. Oh, wrong signal generator. Okay, we'll plug in the okay. So you can see the tuning bump. Now where is it actually focused? The radio's tuned to 1400. You know, it's certainly in the area. Okay, so it's been a couple hours since the last little video segment there when my computer got chock full of files and decided not to work, so I had to sort that out. So, and just before I started the video now, I just quickly checked to verify the local oscillators in both of these radios are hitting the mark at 1400 and at 600. They're exactly right. I've got them exactly right. So that's great. I think what we should do is listen to both these radios at this point. I think they're both really well aligned. Let's see. Okay, let's give these guys a good test here on receiving. So this white loop that you see up here is simply a 3-turn loop of wire, and it's connected to a cable that goes to an outdoor antenna, a long feed cable. It goes to a fairly large outdoor antenna of not a very good quality. But anyway, that puts a little bit of what's outside on this loop, and you see I've got it just physically right up against the antennas here. Help these radios out. So I think it's probably fairly balanced or equal how I've done it. Neither one I can turn off anymore. They're both on. One of them I can't get rid of the sound. This one. And this one the volume is a hair trigger. So I'm sorry for all that, but here we go. We're gonna go up to 16. There's gonna be nothing right down until we get about here. There just never is. But maybe we can compare some of the noises or something crazy like that. Turn this up. I'll stop at that sound because that's a weird sound. Let's see if we can find that same sound on this radio. So you can compare where these two, I'm going to have to make a little change here. I'll lower my camera. Hang on a sec. There we go. That looks like 13 to me. That one looks more like 1275, something like that, 12750, something. Not quite the same spot. Get around with this one. There's another one. Aha, the French station is Radio Canada. I didn't know that. That makes sense. So we'll do the same with this one now. Bottom of the 90 square. I would say about the same, eh? Bottom of the 90 square. Exactly the same. And on the chart, at this location, but we're close to 900. They were matching RF and the local oscillator very closely. 8 here at the time when I measured it, but this, this 8 is 8 plus or minus 4 really when I do that, and they're all pretty consistent in where they were on the dial. That made sense what I just said in that last part. Okay. That's not bad. Let's go a little further now. I hear that. Just moving it off a bit. I have to be careful with commercial music. Can this guy get that? Because that was right at the limit of this radio. It's a great test. Oh. Hey, where'd it go? It may have faded out. It may have faded out. light. What happened there? Oh. Something's fading in and out. Is it the radio? Waiting to see if it's going to fade. It's not this, is it? Moving it? No. I don't know. I'm going to get a copyright hit if I'm not careful here. This radio sounds better. Onward. Yeah, signal to noise to me seems to be much better in this radio. But some strong stations are coming now. Yeah, lots of stuff happening in Canada. Wow, lots of political stuff, societal stuff. Lots of societal stuff going on. The entire teachers unions, all the teachers unions in Ontario went on a walkout today. Let's check this one out. Just mentioned the hereditary chiefs. We have people in Canada upset enough that they're blocking the railways all across Canada. A lot of the railway system's not operating in Canada right now. So in my province, where the teachers are on strike, there's 13 million people live in my province. So when teachers go on strike, I think it's 25,000 teachers. It's a big deal. It's a big deal. Okay, so I passed 610, I'm going to go to 590. Getting 610 is tricky. Let's see if this one can do it. I heard it come out of this one.
Yeah, I heard that.
There it is. 590. This is about the strongest AM station here at my house. All these AM stations down here are about 100 miles away. They transmit 100 to 200.
In the rotation once every 5 days, and that's to me what's harder than most striking is just
Also, it strikes me here in my shop, I don't know if it comes across on the video, the bass seems more pronounced here. This just seems to have a nicer sound to it. That's what I think, based on this. Okay, well, I've just about done, I think I've done everything I can with these two guys. I'm a little worn out at this point, though. Seen enough of these guys today. Thanks a lot for watching, and we'll see what I'm up to tomorrow.